Yes, I know it's upside down. No, in this one it's, don't get me started. That it shows backwards, that's fine. So here we have our nameplate data. And if you guys want to come up here and you can look over my shoulder if you want to, you can watch me do it. So just come around here. And what I'm looking for is the wiring diagram. It says right here is 208 to 220 volts, and it lists some motor leads. Typical industry is going to be 440 to 480 volts, and it has these wires. So there's 9 leads, and if I look on these leads, I will see numbers on them. This says T8. This says this one's come loose. This one is typically wired for low voltage already. But if I look here, I can actually see the numbers on the motor. So here we have a T4, etc., etc. Here's a T5. All right. So I'm going to take these wires and I'm going to connect them like this diagram right here. I'm going to tie 4. If I want to do low voltage, I'm going to tie 4, 5, and 6 together. And then I'm going to tie 1 and 7 along with my power wire. See, L1 is right here. So this is where the power comes in. Right now, you're not going to see a screw terminal connection like this except on large motors. But this is kind of a little demo unit I have. And we're going to connect them here. I'm going to verify that I have this one came loose. Typically, you're going to use a wire nut to do this. You're going to, where these wires come loose, you're going to simply put them in there and screw them together. And we're going to pick our voltage. One of the things we do when we troubleshoot this motor is we can, if we connect it with, I'll go ahead and connect this one. And I have this wired for 220 right now. Hopefully I have it wired for 220. Oh, I had some sort of tool that. So I have all of these split up. Now, hold on a second. No, I'll just go get another motor. Oh. Yeah, I found it. Right here. Here we have another motor. You actually see the wire nuts on that. We'll see how these leads are connected. Pull all of this out. We'll see that we have our power wires coming in. These just so happen to be some 3-phase SO cord, and they are listed in right here. We have that focused up. We have our cord coming in, and we'll see that each one of these, if this is wired for 220, I'll see that if I look on there, that this number is 2. Notice the numbers on the wire. So this is 2 and 8. 2 and 8 are wired together. And in there, it is tied to power. So L1 is tied to 2 and 8 because we've got this wired for low voltage, 220. Trying to get to a motor diagram real quick. This particular motor has a motor diagram on the inside. And so I'll see that 2 to 8 say line. So 2 and 8 are wired to line, so that's correct. And when you put these wire nuts on, and you begin to wire this motor, it is a good idea to twist them and give them a gentle tug to make sure they bite. Because if you look at a wire nut, inside there is a spring type screw that actually grips the wire and twists it up. It twists the wires together and keeps it from coming untwisted. These fail, they rust out, they go bad. So make sure that when you put the wire on there, you tighten it up pretty good, give it a gentle tug, because if that comes loose inside this motor housing, it's going to spark to ground and blow up, cause you to trip the fuse. So what we're going to do now is I want you guys, you're going to actually get a motor. You're going to pull all the wires off. You're going to hook it up in a high voltage configuration. You're going to check the ohms because we can use this, we can check it. For example, if I put my meter on ohms, I go ahead and terminate this back. And all of the motor is hooked up. I have my 3 phases coming off the motor with a green, a black, a red, and a white. So I'm going to check phase to phase. What I'm looking for is if I check that, I see that I'm reading about 22 ohms. So I'm going to grab another phase because this is a Y motor. I know they're all connected. I'm reading between the other 2 legs. I'm reading 22 ohms. So that's what I'm doing. I'm checking between all of these wires right here. And if I check between all of these and I read the same, about the same, it may vary a couple of ohms, 0.5, it may even be 1 or 2 ohms. I know that this motor probably doesn't have any problem because the same size coils should be on each winding, and so if they're wired correctly, I should be reading the same ohm reading across each lead. It will change. So here we have low voltage, which is 22 ohms. You're going to do this when you do high voltage, and then do it at 22 ohms, or at low voltage, so I know you wired the motor right and everything's correct. Also, if we want to see if the motor is shorted, we'll do a section on megging. We don't want to use this green wire. I don't always trust that. What we want to do is we want to check each phase to ground. So we're actually going to find a shiny part of the motor, and we're going to check. And I'll see that my meter now says mega ohms, which is perfectly fine. If I saw kilo ohms or ohms listed there, then I would say this motor has issues. It doesn't really, if they're all wired correctly, you shouldn't have to check each winding, but for grins and giggles, I usually just go through there and check each winding to ground. I see nothing on that one. I'm going to check this other winding, and I see nothing on that one. So I would say this motor is functional. So you guys are going to do that. You're going to pull the wires off. If you're doing this online, you should do that in your Amatrol sections. It has a whole section, and you can actually turn on a little conveyor.